So what we're going to be doing in this lesson is looking at how we can compare distributions. Now that we know how to calculate simple statistics like the mean and the median, the IQR and the standard deviation, we can compare different groups of things. So let's say we wanted to compare men to women, or we wanted to compare summer to winter, or blacks to whites. Different groups of things we can compare with those different statistics. So to give you an example of how you can create groups of things and compare them, let's consider the average daily wind speed for a whole year. So this is data for 1989, and you can see that the distribution is skewed to the right. So most of the days in 1989 had small average wind speeds from 0 to about 4, and then there's a bunch of outliers that skew this data set to the right. But one of the things that we know about weather is that it's very seasonal. Sometimes it's much more windier in the fall or in the spring than it is in, let's say, the summer. And so we can split the data set into two groups. Here they've split it into summer and winter, so they've grouped all those days together. And then they've grouped together all the wind speeds for the days that fall in the fall and winter. And you can see that the distributions are still skewed to the right, but that the average daily wind speeds for the fall and the winter are much higher than for the spring and summer. And this is consistent with what we experience here in Illinois. For the spring and the summer, most of the days have an average daily wind speed of between 0 and 2 miles per hour. But in the winter and the fall, the average daily wind speed tends to fall above 0 and below 4. So it has much windier in the winter and the fall. Now this isn't particularly easy to see in a histogram, but one of the ways that we can make it easier is by using what's called a box plot. And the box plot relies on what's called the 5-number summary. So the 5-number summary is a summary of 5 important positions. The first one being the median, that is the middle point of the data set. We also have the lowest point, the minimum, the maximum, and the quartiles, which I showed you how to find earlier. They're really just the median between 0 and the median, and the middle point between the max and the median. So here we have two 5-number summaries, one for men and one for women. And this data set is for starting salaries. And I will admit that I made these numbers up, but it's mostly just for an example. Below is their two respective box plots for men's salaries and for women's salaries. Now how they are created is started in the middle point. So the middle line here represents the middle of the data point, that median. So for men it's 45,000, for women it's slightly lower at 42,000. The sizes of these boxes then represent that interquartile range. So for men you reach up to the upper quartile, 65,000, and down to the lower quartile of 25,000. For women, you're not reaching up as high because their upper quartile only goes to 45,000 and the lower quartile goes to 35,000. The last two whiskers then, these lines on the end, go up and down to the minimum and the maximum. So you can see that the minimum for men is 18,000 and the maximum is 70,000. Whereas for the women, their maximum is a little bit lower at 50,000 and the minimum is the same at 18,000. So there's a couple of interesting things that you can tell from the distribution of a data set just by looking at the box plot. One is its symmetry. Here, the men's salaries is symmetric, and that's because the boxes are pretty equal on both sides. So the distance between the median and the upper quartile is the same as the distance between the median and the lower quartile. For women, the distribution is skewed to the left, and that's because this lower quartile box is much bigger than the upper quartile box. You can draw box plots yourself, or at this website it lets you draw box plots using just the 5-number summary that's provided for you. So let's go back to our example of average daily wind speeds and compare our box plot to the histogram. The box plot is listed here below, and you can see that it's skewed to the right. The distribution is skewed to the right because the upper quartile box here is much longer than the lower quartile box here. Now some textbooks do box plots slightly differently in that the way they create the whiskers, they only reach up 1.5 times the IQR. And so they highlight then outliers by notating them with a dot or a star. But even with this different construction, the heart of the box plot and its interpretation remains the same. The middle line is still the median, the upper quartile is the upper part of the box, the lower quartile is the lower part of the box, and you can tell skewness based on the symmetry of these two boxes. So to illustrate this comparison even more, we can chop up the data into even more groups. So here we've grouped the data by what month the day falls in. There's 31 days in January, 21 in February, and so on. The middle line here again represents the middle day for each of those months. What's interesting to note in this graph is that the medians for the summer months are much lower than those for the medians of the winter months, and this follows our expectations that it tends to be windier in the winter months than in the summers. The other interesting point is that the distance between the min and the max, these whiskers, are much larger in the winter months than they are in the summer months. And what that suggests is that there's much more variation in wind speeds in the winter months than in the summer months. So not only is it calmer during the summer, but the variation in wind speed is less as well. You can also see that there's a lot more outliers in the winter months in November and December, also telling us that the wind is much more volatile in those winter months than in the summer months. So that's how you create, display, and interpret a box plot. In the next video, I'll go over a problem on how you interpret a 5-number summary.